Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so this is the setup that we have for our situation here. We have two intersecting wires that are completely perpendicular to each other. Then we have points B and points A here. So we have these points are a distance x from the wire, from the vertical wire. I'll call this one. This is the vertical wire, and this is the horizontal wire. So x and y are distances from the vertical for x, and the distance y from the horizontal wire h. And we have the same thing on this side. X and y are equal to each other. And we want to know the magnitude of the net force acting on, or the net magnetic field acting on these points. So let's start with this top one here. So we have two wires. Each are going to have their own equation for magnetic field. B, we have our equation. The magnetic field is equal to mu naught, the permeability of free space, times the current, divided by 2 pi times the distance from the wire, also called r. So we have two cases. We'll need to do this twice, one for BV and one for BH. So BH is going to be the same equation, mu naught times the current times 2 pi times the distance. So let's look at the equation for BV first. So the wire V here on point A. So V is a distance x from A. This is point A here. So we could replace R, in this case, with x, because x is our distance, and we know what x is. That's a good point. We can keep track of everything we're given. So we're told that both of the wires have the same current, and we're given the current. We're given the values of x and y. So at point A, we found we can get rid of the r and put in x for r. We can do the same thing for BH, but instead for BH, it's a distance y at point A. So we can put in y for r here. And we can use those two to calculate the two values here, BV and BH. Now, let's use the right-hand rule, because we need to find direction. So BV, if you point your thumb in the direction of the flowing current, which is up in this case, your fingers will curl around. They'll be going around this way. Here, let's do a little bit better. So they're going to curl around like that. So over top here, and then it goes under. Or you could do the reverse. And then it comes back over. So at point A, these lines are going to be pointing directly down into the page. So here, we have our magnetic field. I'll draw it in green, see if that makes it a little bit easier to see. So here, our magnetic field is going to be pointing into the page. So this is BV. Points into the page. And now let's take a look at BH. So for BH, pointing our thumb in the right direction, our fingers are going to curl up, around this way, and then back down. So that means at this point, it's going to be pointing straight up. So BH is pointing up out of the page. So to find our net magnetic field for this uppercase here, we have to subtract, depending on whichever one is higher. In this case, we have that X is a little bit longer than Y. So that means our BV is going to be a little bit stronger than BH. So we can subtract BH from BV to get our B net. Now, it doesn't matter what order you do this in, because you can define what direction you want to be positive. In this case, I'm going to have coming, so we're going to do the bigger one minus the littler one, which is BV minus BH. So in this case, the direction of BV will be our positive, which is into the page. But it doesn't matter. All the negative sign tells you is what direction you're going in. In this case, it's into the page. We could have had it go out of the page. It'll be the same number in either case, just positive or negative. So our net magnetic field is BV minus BH. So it's the magnetic field from wire V minus the magnetic field from wire H. And that gives you the net. And you would do the same thing for the lower corner down here. You just need your two equations, and you do the same setup, and you'll get the same net force. But we can take a look at directions here. So for BV, at this point, BV is our vertical wire here. We are at distance x, same as in the first step. But in this case, we have our magnetic field flowing. If you point your thumb up, your fingers curl up. So it's going to be coming up and around. Like that. So at this point, it's going to be coming up out of the page. It's going to be the exact opposite of the top side, which makes sense if we've switched over the axis here. So in this case, B is coming out, and the opposite for BH. So once again, right hand rule, point your thumb to the right and curl your fingers for your right hand. They will curl up around this way. Which means that they will be pushing, backwards. Your fingers are curling up and then around like that. They should be pointing in opposite directions, so that's a good catch if you're doing the right hand rule right. So BH is pointing into the page. So you can do the same setup here and end up with a negative number. That's fine. You just want the magnitude of that number, so it doesn't matter if it's negative. Or you can reverse it and do BH minus BV to get a positive number. Actually, that would be in the bottom side. So you could do BH minus BV to get a positive number, or you could do the same setup for this case. It doesn't it doesn't matter. As long as you remember which direction you defined as positive and which direction you defined as negative. And this will give you your net magnetic field. And there you have it.